All right, time for the notes for 5C in the Math 4 course. I usually have a number of orchestra students in the classroom, so I thought I'd toss this in there. All right, today we're still playing with the graph of sines and cosines, but this time we're going to be focusing on period. Well, the thing that you need to know about period is a formula. Period equals 2 pi over b, where y equals a sine of bx plus c. All right, that is the same thing. Now, the thing that gets a little hinky is that what number belongs in the equation and what number belongs as period are not the same. I mean, you use the same numbers, but here you got to divide 2 pi by that number. And so, we're going to see one number in the equation and we're going to calculate something else as a period. So let's see. Well, and let's talk about this in general. So far in all of the equations that we've played with, you've had a cycle of 0 through 2 pi, and that is your period. You go up and down and back to the original starting point again. A cycle and period are usually interchangeable terms. Now, when we start to consider things like what happens when I try to mash more than one cycle into the same length of the x-axis, where the blue line is what we normally deal with, y equals sine x. That's a period of 2 pi. But what's happening with sine of 2x is that you're squashing two complete cycles into the same amount of time, as it were. And so your frequency is going to be a lot higher that way. Instead of a frequency of 1, you have a frequency of 2, so to speak. And we'll get into some issues in the next set of notes when we get in. Next, we're going to talk about sine function and regressions. We're going to go back to that where we'll plug in a table of values. We'll have a line of best fit. We're going to need to know how to type the formula in the first place. And we'll be able to make a projection on what is an equation that fits this curve, and can I make projections on it, for places where I don't have data. So that's we'll save that for next time. But in general, I just want to say that in this general formula, and you'll notice I left out the minus c earlier. The minus c is the horizontal shift, and I said we're not going to play with that as far as this particular unit. Now you'll notice that they're kind of grouped together. There's the amplitude and the period, which talks about how high do I stretch my curves and how many curves do I squash into, from 0 to 2 pi. The other thing is that, these last two talk about shifting the whole thing left and right versus up and down. Again, we're not going to get into phase shift in this unit. I may or may not bring it up at all in this course. I may just leave it for pre-calculus or something. All right. Find the period. Well, we use our formula. And then we simplify. So understand that if you have a 0 and you have a pi over 2, you're doing your whole thing within that amount of time, not just all the way out to 2 pi. So there's a reason why, a lot of these graphs are cut into halves and quarters and such. Now over here, we're going to divide by 1/2. Now, that is like saying this divided by 1/2. Anytime you've divided by a fraction in middle school, they taught you to flip it and multiply. All right, 4 pi. And so there's your period here and your period there. All right, the game is not much different here. And we can't really reduce that, so we're done. Here we're going to divide by 3/4, which instead of dividing by 3/4, we're going to flip it and multiply, which is going to give us 8 pi on top and 3 on the bottom, and that will not be reduced. You would not want to graph these guys unless your graph was split into thirds instead of into halves and quarters. Otherwise, it's not going to be pretty. Now, this guy, we're actually going to graph him. We need, first of all, the amplitude. Since there's no indication of change, amplitude is 1. The period is going to be 2 pi over that 4, which we said was reducing down to pi over 2. So wait a minute now. This is a sine. I'm going to start here, and I'm going to finish not at 2 pi, but at pi over 2. He's done there. We'll cut him in half there. Remember, he usually goes up, then down. Well, he's got an amplitude of 1, so he's going to go up there and down there. And then the rest is just simply, and the fun part is that you have to remember that you have the entire wiggle up and down inside of one set of lines. Oh, I went a little far on that last one. All right, not perfect, but it's there. Okay, then we're going to graph sine of half x, which our amplitude is still 1. And our period is going to be 2 pi over 1/2, which I'm going to flip it and multiply. Which means our period is 4 pi. Now I'm going to stretch out our graph a little bit. We're going to start here, and we're going to finish out here at 4 pi, which means that halfway is at 2 pi. Our amplitude is 1, which means we're going up 1 unit in the middle, down 1 unit in the middle of the other. And let's finish the rest of that. Okay. With these, it's kind of like giving you an equation and saying, name all of the shifts. Well, that's what we're doing here. So the negative tells us that we are going to flip on the x-axis. The 2 says that we have an amplitude of 2. Because there is no, there's an understood 1 in front of x, That means that my period is going to be, well, 2 pi divided by 1, which is 2 pi. And then there's going to be a shift going up 4. All right, let's play the same game over here. The 1/2 represents the amplitude. And the 1/2 there is going to affect our period. 2 pi divided by 1/2 equals 2 pi times 2/1, which is 4 pi. And there's nothing else on this one to change. Okay, on this set, the negative up front is going to mean flip on the x-axis. I'm going to go ahead and deal with the shift down 2. And then the rest is going to be about the calculations of period. 2 pi divided by 3/2. Now we said that that is the same as multiplying times 2/3. That's going to give me a 4 pi on top, 3 on the bottom. And again, glad I don't have to graph it. All right, this one, the 4 is going to be our amplitude. Because there is an understood 1 in front of the x, my period is going to be 2 pi over 1, which is 2 pi. And then we will shift up 1. And that should do it for them. Now we write this the other way. They give us the changes, and we write an equation from it. Now, this is going to require a bit of calculation for the period, because instead of going from the equation b to the period, now we're going from the period back to the equation b. I need to figure out, if my period is pi over 2, what kind of number am I going to stick in front of x? So let's see now. It's y equals sine of x, amplitude of 2, and something x. We know that we're going to have something there. And then up 1 means plus 1. Now we need to figure out if the period equals 2 pi over b. And I already know the period. Cross multiply. I get pi times b equals 2 times 2 pi. B pi equals 4 pi. I guess what b is. All right, here my amplitude is 1/3 cosine. Reflect across the x-axis means that this is going to be negative up front. If the period is 2 pi, remember if it's 2 pi, we don't have to change anything. That's like 1x. And we're done with that one. Now we have 2 graphs, and I believe we're done. So this one we're going to flip on the x-axis because of the negative. We have an amplitude of 2. We have no shift. And then we've got the 2 there in front of the x, which tells us that the period is going to be 2 pi over 2, which is plain old pi. Now, we didn't have to shift up or down, so I can start from here. And our period is pi, which means we're going to end here, and halfway is going to be back here. Now we're still talking, oh, that's right, we flipped on the x-axis, so instead of going up, then down, we're going down, amplitude of 2, and then up 2. So we'll do that. Okay. And then we'll go down, and then up, and and down, and then up, and up, and down, and up, down, up, and down. All right, the last one, we know that our amplitude is 1. We know that our shift is up 2. And then we need to figure out our period, 2 pi divided by 2/3, which means that I'm going to flip and multiply, which is going to give us 6 pi on top, 2 on the bottom, which can be reduced down to 3 pi. My period is going to be 3 pi. Now, wait a minute now, before I even draw this, there's a shift of up 2, which means I need to draw my green line first. And then from the green line, it's going to go up and down. But my cosine always starts at the peak, which our amplitude is 1. That's going to be up here. And I'm going to be all the way down at 3 pi. And when I come back for the middle, it's actually going to be not 1 unit up, but it's going to be 1 unit down. And then my halfway points, I'm going to have to get, they're not going to be directly on across grid. But anyway, we can still use what we got. And then we can complete out. Oops. And then go up like that. And no, wait a minute. Sorry. Mr. G did not get enough sleep last night. Remember, we're supposed to only go like 1.5, and then 1.5, and then 1.5, and then 1.5. All right, that looks more like it. Now I think we're done.